Okay, so hope everybody's having a good day. It is the last day of the school week, the first week back after vacation. So I'm thinking it was a very long week. I'm sure you guys were probably thinking the same thing. But I want to go ahead and move on to the next section today. We'll go ahead and work a few problems together. We'll do the same thing on Monday, and then hopefully by Tuesday, we'll be able to get to these here. This is going to be our next section. You got a sheet that has nothing but these trigonometric identities listed on here, and these are all properties that are true. So my goal is by Tuesday, we'll go ahead and move past the inverses. We'll go ahead and start looking at expressions using these identities. So it'll be just another type of problem, but we're still working with trigonometry. So that's where we're headed. The good news is, like I said, today and Monday, we're still just working with inverses. We've been working with them all week. Hopefully you're starting to feel pretty comfortable with them. If not, again, we got plenty more time to go ahead and review them. But we are going to have probably next week some type of quiz or exit ticket over some material again, just to make sure that everybody's still up to speed. Your test is coming up on Thursday the 24th, so 2 weeks from yesterday. So anybody have any questions on what's going to be happening as we push through next week? Okay. Well, we've been dealing with sine inverse, cosine inverse, and tangent inverse specifically. And remember, these are the ratios you're allowed to put in. These are the angle measures we're allowed to get out. And I did want to go ahead and spend a little bit of time talking to you about the inverse trig functions for the other three, the reciprocals. But I'm going to go ahead and do it in a really straightforward and easy way. We're going to find those by taking the reciprocal. Okay, so for example, what's the reciprocal of cosine? Oh, secant. Okay, the reciprocal of secant. What's the reciprocal of sine? Cosecant. And the reciprocal of tangent is cotangent. There we go. So this is what we're going to be doing. For example, if I were to have secant inverse, remember that little -1 tells me we're dealing with an inverse, of 2, I'm going to go ahead and say cosine inverse of 1/2. I'm going to take the reciprocal of the trig function and then the reciprocal of the expression that I'm given. See, once I take that reciprocal, we put it in terms of cosine inverse, sine inverse, or tangent inverse. We've already been working with those. So really the only new additional material today is taking the reciprocal. Now, one other thing I do want to go ahead and point out, if you're looking at your notes, the left column versus the right column, some of these have the word arc in front of them. That's just a notation. If you ever see a trig function with the word arc, A-R-C, right in front of it, that's just telling you we want to take the inverse. It's just another way of writing it. So for example, if you had sine inverse of x, that is exactly the same as saying arc sine of x. Okay, so don't let that throw you off at all. It's just another way of saying it. Okay, another method. It's still going to be worked the exact same way. So secant inverse, I'm going to take cosine inverse of the reciprocal. Cosecant inverse, sine inverse of the reciprocal. The only one we want to be careful of is going to be cotangent inverse. And I'm not going to get into the details why, but you have these three possibilities right here. And it depends on the ratio that you're given. If that ratio is positive, well, then you got no problems. Tangent inverse, you take the reciprocal. Okay. If that ratio that you're given, whatever's inside cotangent inverse, if it happens to be negative, well, then you're still going to do the same thing, tangent inverse of the reciprocal, but then you're going to add pi. Okay. And then if the value is 0 itself, that's the one time we don't have to do anything. I know immediately that the answer has to be pi over 2. Okay. Because we're still going with the same idea. I'm only able to plug a ratio into an inverse trig function. My answer is going to be a what? An angle measure. There you go. Yeah, exactly. Okay, so let's just get right into it. Let's try an example and see what you guys think. Hey, yeah. That means negative. If it's less than 0, that means negative. The greater than 0, that's the positive. Okay. So see, for x, whatever you're putting into cotangent inverse, that covers all your bases. Positive, negative, and 0. Okay, so let's try a problem here. I've got arc cosecant of 2. Oh, wait a minute. What does that arc mean? Remember, that just means inverse. So if you want to rewrite it, if you want to go ahead and say, cosecant inverse of 2, perfectly fine. Okay. But now these new 3 trig inverses, we're going to solve them by taking the reciprocal. Okay. So this is the same. What's the reciprocal of cosecant? It was sine. So I'm going to take the sine inverse. What's the reciprocal of 2? Oh, now we're not changing the sign. We're not taking the opposite. The reciprocal is just to flip it. So right now, what does 2 look like if I were to make him a fraction? 2 over 1, right? So the reciprocal would be 1/2. There you go. And see, that's a problem that we're already accustomed to solving. Okay. Now, sine inverse, is he in quadrant 1 or 4? Why 1? Because it's positive. Okay. So just like we've always done, I got a grid. I'm going to draw a terminal side here in the first quadrant, connect it to my x-axis. All right. And I'm looking for this angle measure right here, rotating off standard position. Well, remember, sine is y over r, right? Okay. So the y is always the vertical, the up and down. It's directly opposite. So this would be the 1. The 2 is going to be the r, the hypotenuse. Okay, but there's something I'm missing. Yeah, I'm missing the adjacent, the x value. How do I find him? Pythagorean theorem. So let's say this is x. What's the equation I would use to help me? Okay, is everybody okay with that? X squared plus 1 squared equals 2 squared. Okay, well 1 squared is just 1. Equals 2 squared? 4. Then I would go ahead and subtract the 1. So x squared is equal to 3. And then x, we're going to find that by taking the square root. And just what we've been doing all week. So here's my question. Is it a special right triangle, or am I going to have to get out the protractor? Okay, so which one? Now why immediately is 45-45 gone? There you go. If it's a 45-45, these two sides, the legs, the ones that form the right angle, they have to be exactly the same. Okay. So let's see. What are the what's the behavior, the patterns you notice to tell you it's a 30-60? What's the relationship between the shortest side and the hypotenuse? There you go. The hypotenuse should always be double the shorter side. Okay. And the longer leg should be the shorter times the square root of 3. And we know 30 is always across from the shortest. That would have to be 60. Bless you. Okay. So what's the angle I'm looking for? 30 degrees. So arc cosecant of 2 should be 30 degrees. Now, what if I wanted that in radians? Okay. So what is that? Pi over 6 or pi over 6? Okay. Now, let's see if we're actually correct. Let me go ahead and type it in. Now, my calculator is still going to be in degrees. And I had forgotten previously to go ahead and pull up my calculator, and the touchscreen is apparently not letting me do that. So just give me 1 second for it to come up. Anybody got any plans this weekend? Work? I'm going to sleep in. I'm very tired. Who's going hunting? Who's going hunting? Okay, where are you going hunting? Okay, what are you going to hunt? Deer? Duck. Okay. I don't know. Is it deer season at all? Or is that already over? I don't know. It's rabbit season. I like that. That's a good joke. Okay. So let's see here. What was it? I'm going to hit trig. Oh, might help if I get to the calculate screen first. So trig. Now you'll notice, oh, it's doing the same thing it was the other day. But I'm going to go ahead and choose cosecant inverse because that's what I'm looking for. Let me hit escape. I don't know. It hasn't done that actually in quite a few years. It didn't do it last year at all. So there you go. But arc cosecant of 2, remember what did we get from my answer? We got 30 degrees. My calculator's still in degrees, so I push enter, 30 degrees. Okay. All right. Exactly what we've been doing, we're just taking the reciprocal. Okay. one extra step to our work. All right. Okay, so let's try another one of these. Secant inverse of negative square root of 2. Okay. So this one has the negative 1. Remember, this would be the same if I were to write arc secant of the negative square root of 2. That arc simply is a new way of writing the inverse. Okay? So let's see here. What's the reciprocal of secant? Cosine. So I'm going to go ahead and write cosine inverse of, and what's the reciprocal of negative square root of 2? And think about it, how would I write that as a fraction? Okay, put it over 1, and then I would just flip it, right? So this is negative 1 over the square root of 2. Now, normally when we see that radical in the denominator, we go ahead and rationalize it. We don't have to. Now, if you want to, does anybody want to? I would probably just go ahead and use the side lengths you have. I think, rationalizing it would probably just give you a little more work. But I mean, in math, that just means it's more fun, right? Exactly. Okay. But here's my question. What quadrant would cosine inverse put me in? 1 or 2? Why 2? Because it's negative. If it were positive, then it would be in the first quadrant. So I draw my terminal side. Okay. Just like this. Okay. Now remember one thing when we're trying to figure out cosine inverse and it's in the second quadrant, we always rotate from the positive x-axis. So we are going to find this angle right here, but then we're going to go ahead and see what the difference is between it and 180. Okay. So let's see. We have my fraction. We know it's negative 1 over the square root of 2. Well, what's cosine's ratio? Sine was y over r. So cosine is x over r. Okay. So the x value is 1. The radical, or excuse me, the radius is the square root of 2. Which one of those would have the negative? There you go. Because remember, from the origin, if I were to go left, that's a negative number. It just tells me the direction, right? Okay. Any questions on how I'm setting this up so far? Any problems? Okay. Hey. Oh, because think about if you were plotting a point. If you were at the origin, okay, and I wanted to plot a point, the first thing I do is move what 2 possible directions? Left and right. But how do I know to go left or right? What tells me that? There you go. If it's positive, you would go right. If it's negative, well, then you would go left. And from that, then you move up or down. But again, how do I tell? Yeah, so positive or negative, right? Well, the same thing applies here. Okay. Like if we had a triangle in the 4th quadrant, the x would be positive, but the y would be negative, because to get to that point, you'd have to go down. So see, we're just applying the sign to the side. Does that kind of help out? Okay. So let me take that off real quick. Slowly but surely. Of course it did. There we go. Okay. So let's see here. Now, what do I do? There we go. So I need the third side because I need to see if it's a special right triangle. Okay. So let's see here. What would that be? This is y we're looking for. So what's my equation? Okay. So negative 1 squared plus y squared. Okay. Those are my legs. They form the right angle. And it's always equal to the radius squared, the hypotenuse. Okay. Now remember, that hypotenuse, he's always, always, always positive. Well, what is negative 1 squared? 1 plus y squared is equal to 2 when you square a square root. Now I'm going to subtract 1. Okay. So y squared is equal to 1. So what's y? Yeah. And what's the square root of 1? 1. So there we go. That is my next question. Is this a 45-45? Are those two sides the same? Okay. I see some yeses, and Brandon says no. What do you guys think? Think about in terms of length. Are they the same? Yes, but I see where the confusion is coming from. That's a 1 and that's a negative 1. That's exactly right. Okay, remember, negative is just for direction. The negative is just telling me I need to go left. This length is still the same as that length. So I know this is a 45 triangle. So is secant inverse of negative square root of 2 45? Remember, what did I say at the beginning? If it's in quadrant 2, there we go. See, if half of the circle is 180, how far do I have to rotate so that 45 is left over? And I believe it was Israel who just told me that, 135. Okay. So this is 135 degrees. In fact, let me check it out on the computer. So secant inverse. Let's see if it does the same thing again. Okay. And it is not. There you go. See, I don't know why sometimes it does and it doesn't. So I'm going to choose secant inverse, which is arc secant. And then what was it? Negative square root of 2? Is that right? Okay. Let me type it in. We said 135. That is exactly what we got. Okay. Anybody confused? Anybody having a hard time with these? Okay. Well, let's try our next one. Okay. So now this one, C and D, these are the only ones that we really have to be careful about. Okay. For cotangent inverse, remember there were 3 possibilities, and it depended on what your ratio was. So I'm looking at C. It says cotangent inverse of negative square root of 3. So this is definitely a negative ratio, right? So because it's negative, I've got to use the middle one. Okay. Is everybody okay with why I'm choosing the middle one? What if it were just a cotangent inverse of the square root of 3? No negative. Then I would use the first one. There you go. So cotangent inverse is the only one that's a little squirrely. And I'm not going to worry about getting into it. I mean, that's stuff you don't need to know. But everybody's okay why we chose the middle one? Okay. So I am going to go ahead and take the reciprocal, tangent inverse. I'm going to take the reciprocal of the negative square root of 3. The only thing I need to make sure of is just add pi at the end of that. Okay. So this would be tangent inverse of, what's the reciprocal of negative square root of 3? Yeah, negative 1 over the square root of 3. And then we don't want to forget, add pi, just like the formula tells me to. But that'll be the very last thing we do. Okay. This right here, we're still going to go ahead and solve it like we have been. Okay. All right, so tangent inverse, what quadrant is this in? We know it's restricted to 1 and 4. Why 4? Okay, because it's negative, right? We always choose the quadrant based on sign. I always connect it to a x-axis. So this is what I'm looking for. But remember, we're in quadrant 4. So this portion right here, the tangent inverse, guaranteed whatever I get, he's what? He's negative. Remember, sine inverse, tangent inverse, if it's in quadrant 4, guaranteed that's negative. Now, it may or may not still be negative. The final answer just depends on what we get when we add pi to it. Is everybody okay with that? Okay. So let's see. We already have my fraction. We've said the ratios. Cosine was x over r. Sine was y over r. What's tangent? That was y over x. Okay, so negative 1 over the square root of 3, that's y over x. Okay. So just think about moving from the origin to the other point on your triangle. Okay, the x value is the square root of 3, then I got to move down 1. Which one of those would have the negative?
1.
The 1, because you're going down, that's right. Okay. Everybody okay? All right. Well, now what? Pythagorean theorem. This time I'm looking for the radius. There you go. Whatever we're squaring and then adding, those are always the two sides that form the right angle. Okay. All right. You know why that angle is never wrong? Because he's always right. There you go. Feel free to share that one with your friends later. Sure. Anyways, what is a negative 1 squared? 1 plus square root of 3 squared? 3. Radical cancels. Equals r squared. So 1 plus 3 is 4. So ultimately, to get r, I got to take the square root. So the radius is 2. So what do we think? Yes or no? Is it another special right triangle? Is it a 45, 45, 90? Why not? Okay, well, one, the two legs are not identical. Okay, remember the sign does not matter. Is it a 30, 60, 90? Yes. Let's see. The shorter leg, and again, don't worry about the negative. That just tells me direction. Is the radius double the shorter leg? Yeah. Okay, 2 is double 1. And if I take 1 and multiply it by the square root of 3, that does give me square root of 3. So here's the question. What's this angle right here? Is that 30 or 60? That's the 30. Because it's directly across from the smallest side. So that means this one has to be 60. Okay. Now remember, because we're in quadrant 4, what did I say just a moment ago? This is negative 30. So this right here actually came out to be negative 30 degrees. So we can do this one of two ways. Do you want to stick with the degrees or you want to go with the radians? Stick with degrees? Okay. So let me take this off real fast. Is everybody okay? We just found that tangent inverse of negative 1 over the square root of 3 was negative 30. Now what I want to do is add pi to that. Remember, that was coming from the notes I provided. But what is pi in degrees? Is what? Oh, not 90. That's pi over 2. 180. Pi is 180 degrees. They're equivalent. So let's see. What's a negative 30 plus 180? Hey. So the final answer should be 150 degrees. Okay. How you doing, sir? All right. Oh, the negative 30 plus the 180. Remember, we decided to stick with the degrees this time around, and pi is 180 degrees. So I just replaced it. Mm-hmm. And let's see. The problem was cotangent inverse of a negative square root of 3. Let's see if we do end up with 150. So here's the trig again. There it goes. Nope. Come on. There we go. I don't know. I know. And it reminds me of that old game show. What was it? The Whammy? Where it would no whammies, no whammies. You remember when they'd stop and then it showed that little cartoon character? Yeah. That was an old game show. Yeah, exactly. Actually, yes. The same thing happened on The Price is Right. There was a gentleman a few years ago who did extraordinarily well, and their first thought was that he cheated. And he really didn't. He watched the show every single day, and if you really get to watching it consecutively, you'll notice they use a lot of the same brands. And the prices are going to remain pretty consistent. So he watched the show for so often, just like that other guy. He watched the show and he would calculate when, if you were to hit it, where it would stop. And then when he got on the show, he did amazingly well. No whammy. And he did not get any whammies. What was this? Negative square root of 3. Negative square root of 3. And we said the answer was what? 150? 150. Okay. There we go. Is anybody having problems? Any questions? Okay. All right, let's go ahead and try D. Arc cotangent of 1. Okay, wait a minute. What's that arc mean? That's just inverse. So arc cotangent of 1, remember that is just cotangent inverse of 1. Okay, just another way of writing it. All right. Now, because it's cotangent, we want to be careful. Is it positive or negative? It's positive, so when I look back over here at the notes, do I want to use the same formula I just did or another one? This time I want to use the first one because the 1 is positive. Okay. So all I want is to take the reciprocal of the trig function, tangent inverse, and then I'll just take the reciprocal of the ratio. But this one you'll notice, if you take a look, I'm going to go ahead and say tangent inverse, but what's the reciprocal of 1? It's still just 1, right? What quadrant would this put me in? Why first? Because it's positive, okay? So I'm going to go ahead and say, okay, here we go. Connect this. Now, how can I write 1 as a fraction? 1 over 1. And we said that cosine was x over r, sine was y over r, tangent is y over x. Okay, so this is what I'm looking for right here. Okay, so the opposite, the y, is 1. The x, that horizontal, is 1. All right. And now what? Okay. So there you go. So 1 squared plus 1 squared is equal to r squared. So 1 squared is 1. 1 plus 1 is 2 equals r squared. And then r would be the square root of 2, right? So here's my question. Is it a special right triangle? Okay. What is it? What immediately tells me that? The two sides are the same. Okay. So this one right here, arc cotangent of 1 should be 45 degrees. Or pi over 4 if you wanted it in radians. Okay. Now remember, this one used a different formula, so I did not have to add pi to it. That's only if it's arc cotangent and the ratio is negative. Okay, what do we think? Anybody having a hard time? Okay. Well, I'll tell you what, we'll go ahead and do one more problem, and then we are done for the day. Okay. So odds are on this next one, we can probably expect the triangle to what? There you go. So will it be special? No. Okay. There you go. There you go. Yeah, everything's special in that. Okay, well, let's try this one. Find the value of arc secant of -3/2. Okay, well, arc again just means inverse. Okay. So what's the reciprocal of secant? Cosine. Okay. So I'm going to go ahead and say, do you want me to stick with the arc or actually use the -1? Use the -1. So I'm going to say, let me write this up over here so I have a little more room. So this is just cosine inverse of, and now take the reciprocal of what's inside. -2/3. Okay. Okay. So Kiana, let's see how you're doing. Cosine inverse has to be in 1 or 2. This one or this one. Which one do you think he's going to be in? What? Yes. All right. So it's in the left. So I'm going to go ahead and draw my terminal side right here. All right. So there we go. Now remember, again, we're in the second quadrant, so we are going to be finding this angle right here, but the true angle is when we measure from the positive x-axis. Okay. So let's see here. What is cosine's ratio again? I keep forgetting. Okay. So x over r. So that means x, the horizontal, this has to be 2. The hypotenuse has to be the 3. Which one has to carry the negative? The 2. I like that. Which one has to have the negative? The negative one. Here we go. All right. Is everybody okay? Why? The radius is always, 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 well, it's a hypotenuse, but positive. There we go. Okay. All right, so now what? Okay, so we're looking for y. Let me go ahead and move this protractor out of the way a little bit. So what's my equation here? Everybody's okay? So a negative 2 squared? 4. Okay. Plus y squared is equal to 9. So y squared would equal 9 minus 4, 5. And what's y? Square root of 5. Okay. Okay. Now, is it 45, 45? Nope, definitely not. Okay, square root of 5, it does not equal negative 2. Is it 30, 60, 90?
Yeah. Wait, no.
Now, be careful. The shorter side is the 2, is 3 exactly double the shorter side. And also, if I take the shorter side and multiply it by the square root of 3, will that give me square root of 5? So see, it's neither of the two. This is why we have to use the protractor. Now, one of these is going to be pretty easy. I always like to go ahead and do these in centimeters. So let's say this origin right here is what I'm going to have here. So I need to go 2 centimeters left and then square root of 5 centimeters up. Okay, so let me bring this guy out real quick, get him correct. All right, so I'm going to say 2 centimeters left. So let's say right about there. See where I made my mark? Now, the other problem is, how have we accurately been able to get a measure if it's not a integer or a whole number value? Okay, there you go. If we go ahead and take this, the square root of that 5, if it'll enter, it does say 2.23. Now, that's in centimeters. He multiplied by 10. He's changing it to what? Millimeters. There we go. That'll make it way easier to get an exact value. And it just moves the decimal over. So we need to go up 22.4 millimeters. Okay, so I'm going to take the ruler. Now I'm going to start it right at the mark, and you'll notice that I'm going to go ahead and put it where the mark begins, not the edge of the ruler. And I want to go up, was it 22.4? So 10, 20, 22.4, maybe about right there. What do you guys think? Is that good? Okay. So now let me move this guy out of the way. And starting at the origin, I'm going to go ahead and draw a line right through that mark that I made. What the heck happened to it? What? What happened to my work? What? Well, I had all that work. Okay, hang on. Let me move that. Let me do this. Move him out of the way. He bounced back. Okay, so now I'm going to do this. There we go. So now I'm going to take this protractor. And how do I measure using this? There you go. This crosshair is right here. On some of yours, you've just got that little open circle. You're going to put that right on the origin. So I'm hoping I'm not too far off on this one. Okay. Yeah, see, mine looks off. I'm getting 130. Because remember, in the second quadrant, we have to start rotating over here, right? So Brandon says 133. I got 130. What would you like me to put? 132.5. 132.5? Okay. Well, let's actually see how close we got. What was the original problem? It was secant inverse of negative 3/2. So let's see. I'm going to go ahead and go here. Secant inverse of negative 3 divided by 2. 131.8, so about 132. So I was a little off, and that's okay. All right. Is anybody having problems? Okay. All right. Well, if I can get you to put your protractors back up at the front, calculators back in the charging bay, that is all we got for today.